example number 2, I'll show you how to do a video of using it on a calculator and kind of the buttons to push. So here we have a number of years since a person is or a company has opened a coffee shop right here. So basically here are my X's that I want to enter in from 0 to 40. So I want to hit stat and enter for edit, and here I'm going to put mine on list 5. Okay, so L5 from 0, 16 all the way to 40. Okay, and then I want to put the number of shops, how many shops they have in those years, as my L6. So I'm going to go from 1 to 17,000. So I go over 1 for year 0 and then make sure they're all in there correctly. 17,000 is 40. So I need to make sure I have the same number of Y's as I do X's, or it's not going to work. Okay, so once that's in there, I want to make sure, because what I want to do is see, does this data, the scatter plot, represent a linear equation? Does it represent maybe a quadratic? So then I could model it and see, you know, if I want to predict maybe what's happening in year 42 or what's happening in between here, right? Maybe at year 10, how many stores do they have? I can write an equation maybe as a linear equation or quadratic or as an exponential and see which one best fits that, okay? And so I'm going to do that by first turning my diagnostic on. And so I hit this catalog button, which is by the 0. So I'm going to hit second 0, which gives me a list of options here in alphabetical order, and I want to go to D for diagnostic on. So my D is right here by the x to the -1. So I want to hit alpha x to the -1, and it didn't work, of course, so I have to do it again, x to the -1, and there it moved down to D. So now I'm just going to arrow down until I get to diagnostic on. Diagnostic on. I want to hit enter and then enter again. Now it's done. So the diagnostic's on. So now I can predict what might happen as an exponential or a quadratic or as a linear equation. So here I make sure my second stat plot is on. So I go second y equals, hit enter for that stat plot, make sure it's on. Yep, it's highlighted in black. Highlighted in black is a scatter plot. Now I need my X list, right? So I want my X list to be L5, so I'm going to hit second stat, choose my list. My X list needs to be 5, enter, and then my Y list needs to be L6, so second stat, go down to L6, hit enter, and now I can graph that. But you notice I don't really see anything on here. That's because I need to adjust my window. So my smallest Y, or my smallest X was 0, and my largest was 40, so I'm going to go to my window, and I want to go maybe, yeah, sure, -10 is fine, but maybe, yeah, -10 is fine, to 40, maybe 50, a little bit past that so we can see everything in our window. 50, there we go. Okay, and scale, maybe I want to scale by 5s. Then I notice my Y values go from 1 all the way to 17,000. So maybe I should start at maybe -1,000 and go to 20,000. And then maybe I want to count by 5,000s or so, or 2,000s, I guess I could do. 5,000's fine. Okay, now when I hit graph, now I can see that data on there. And it looks kind of like exponential, right? We grow here, and it grows really fast, and then it kind of levels off. So what's the best one to use? Is it a linear, is it quadratic, or exponential? Okay, and so how I get there is I'm going to hit stat. I'm going to go over to calculate, and I'm going to go down to, maybe it's a linear equation. So I'm going to do a linear regression. I'm going to hit enter. My list is L5 for X list, Y list is L6, and then this store equation, what this stores, it stores my linear equation in my Y1. So then I automatically will graph it in there. So how you do that is hit this vars button, V-A-R-S, okay, and then you go to Y-vars, second one over, and then you hit function enter, and I want it to be my Y1. So now when I go down to calculate, hit enter, it's going to give me my A and my B, my slope and my where it crosses the y-axis. Okay, and this r squared is how close this is to our data points, how reliable this line is. So the closer this number is to 1, the more reliable it is. So right now it's 0.6, so it's kind of really not reliable. Okay, so when we graph this, we can see that blue line is our linear equation that models that. We can see all these points are way off, right? So maybe it's a quadratic. So I go to stat, go to calculate, go down to quadratic regression. So I go to quadratic regression, hit enter. X list, Y list, store frequency. Here, I want to do vars, but I want to change it instead of at my function, I want to do Y2. So then when I calculate, it gives me an R squared of 0.9, which is kind of reliable. It's almost close to 1, 0.95. So now when I hit graph, we can see the blue one's the linear. The red one, it's a little bit off over there, of course, but this kind of looks more like my data, right? Right there. So it's a little bit closer representing that data right there. Okay, what about an exponential? So hit stat, go over, go down to EXP regression. That'd be an exponential. Enter. Y list, X list, store, vars, go over Y vars, go down, hit enter on function. Now Y3. Hit enter, go down to calculate, enter. Now this is 0.96. Okay, so the 0.96 is a little closer than 0.95. It's closer to 1, so this is probably the most reliable. We can go ahead and hit graph. There's our linear, there's our quadratic, and here's our exponential kind of in black here. It goes up. So now we can go ahead and predict which one's maybe best to find out, okay, in year 10, in between here, year 10, how many stores did they have? And then maybe in year 42, how many stores? So I can hit second table. So then we can predict year 10. We go down to our X of 10 years past opening. We can see our linear one, negative 2,637 stores. Can't have negative stores, right? Our quadratic would be negative as well. So we can see at 10 stores, that kind of makes sense. In year 10, they have about 10 stores in there. So that looks good. And then how about in year 42 since opening? So we go down in year 42, X is 42, and 1,300 stores, we know they have more than that. 20,000 stores, that's maybe more predictable. But this one is our exponential, so that was the line of best fit kind of. Our R squared was closest to 1 there, so we would use this, but we can see that's probably way out of line because we know on an exponential that it just grows and grows and grows and grows. So it's just going to keep on going, right? So that's why you kind of don't predict outside the values that you have. We can predict inside, like year 10 is perfect, but outside our values of 40, we don't want to predict outside of that because we can see exponentials just grow way too fast, right? Okay, so that's how you use a calculator on example number 2.